Welcome. Today we're going to be working with section 6.5. This is some applications of percent problems. There's two objectives here. We're going to solve some applied problems using the 5-step problem solving process, and then we're going to look at percent of increase and decrease. So you can solve many of the problems that we've got here using that 5-step problem solving process. There are some worked out examples on page 367 through 9. Please read them before trying the practice problems. Here's a sample that you can use. You can print these notes and use them as an example of how this works. Here's a problem like the ones you're going to solve. It says there are about 130 million workers aged 16 and over in the 15 largest cities in the United States. Approximately 11.2% of them carpool to work. We want to know how many workers in those 15 cities carpool to work. We want to familiarize ourselves with the situation and write it in the form of some percent of something equals something. Remember our percent, our base, and our amount, our basic percent statement. So let's look back over the problem. We need to sort through it a little bit because there's some extra numbers there that we aren't going to use, right? We aren't going to use the 16 or the 15. What we're going to use is the 130 million workers and the 11.2% of them. So we have a large pool of workers, 130 million of them. Of that 130 million, part of them, or 11.2% of them, carpool to work. See, we have the of here in the statement in the problem. First thing, please don't be intimidated by the 130 million statement. If I wrote 130 million out, I'd have to add 6 zeros, and it'd be a gigantic number that looks like this. We can just use the 130 and then add our million at the end, realizing we're talking about millions. So we have some percent of 130 million equals the amount that carpools to work. So let's write it in that form. We have 11.2% of the total 130 million equals our amount. Now I can take that and I can either translate it into a percent equation or a proportion. My percent equation would look like this. 0.112 times 130 equals my amount. Remember, I take my percent and convert it to a decimal, left out of percent. To do this problem, all I have to do is take 0.112 times 130, that's my amount. I'm going to get 14.56 million. Okay? Didn't have to do a lot of vertical format there, did I? Because all I had to do was multiply. Let's look at the proportion. With the proportion, I'm going to put my percent over 100 because that's what it means, 11.2 out of 100. And remember, my base goes on the bottom on the other side of the proportion. The base is my total amount. I'm looking for some amount of that. Okay, so here's the proportion. I'll use the vertical format, multiply diagonally 100 times A, and 11.2 times 130. Do my cross products equation. 11.2 times 130 is 1,456. So now I have a little equation. When something's multiplied, you know you divide it. So I'll divide both sides by 100, and I get 14.56 like we got on the other one. So the equation method can be very short. Sometimes people have trouble remembering the whole percent to decimal and decimal to percent thing. The proportion way, you write your proportion and do the cross products equation. You can check your work by using the formula rate, which is the percent, times the base always equals the amount. Well, that's kind of what our equation was, wasn't it? My rate, 11.2%, times my base, 130, equals my amount. And you have to do 0.112 times 130. And that's my 14.56. So if you're using the proportion method, you can always check and see if you've haven't made a mistake anywhere. Then we want to state the answer in the form of a sentence. There are 14.56 million, don't forget the million, workers who carpool to work. If you want to write that out, here's what 14.56 million looks like. Move my decimal 6 places to the right. 14,560,000 workers. So that's one kind of problem you'll be doing, is problems that use percent. The other kind of problem that you're going to do involves percent of increase or decrease. And there's a couple of examples here that we can use to practice percent of increase and decrease. There's a little formula that looks like this. The percent, doesn't matter whether it's increase or decrease, equals the amount of change divided by the original amount. We're going to see that here in just a second in this first example. Okay, so Jody buys a new car. Started off $14,500. Unfortunately, after 1 year, her car had depreciated. That means it lost value. It went down in value by $2,500. And like our textbook, there's often more than one question asked here. We want to first find the percent of decrease, and then we want to find out what her car was worth after 1 year. To find the percent of decrease, you're answering this question: the amount of change equals what percent of the original amount. So you can fill in the blanks in this little formula, okay? The amount of change is the $2,500. We're trying to find the percent. Of means times, and my original was 14,500. I have a little equation here, don't I? I'm going to divide both sides by 14,500. When you do that, it doesn't come out to be a nice even percent. You get something like 0.1724 decimal. That's my percent. Well, of course, that's the decimal format, isn't it? To change that into its percent, I'm going to go right into percent. RIP. It's going to be 17.24%. So her car depreciated a lot, about 17%. Notice that what we did over here when we were solving our equation, we had the amount of change on the top, that's the 2,500, and the original amount on the bottom. So I could quickly do percent equals amount of change divided by original and get my answer using this little formula. And that's okay if you do that. You just want to make sure that you're using the correct numbers. Then we want to know how much your car was worth after a year. Well, it started off with $14,500 and it lost or subtracted $2,500. That means it was worth $12,000 after 1 year. I know that it seems kind of silly to write out that subtraction problem, but it's important to see what numbers you're using and where you're coming up with them and what you're doing with them on some of these. So please do show your addition or subtraction so that I can know kind of what's going on. The second problem here, we have Brady. Brady earned $43,500 last year in his job as an accountant for a local business. He saved the business $10,000 by finding a billing error and was given an 8% increase in salary. So his salary went up. This was an increase. Our first problem was a depreciation or a decrease. This is going to increase. We want to know how much his increase was, and we want to know what his new salary was. Does the $10,000 come into play in our calculating? No, it does not. It's just a piece of information. We have his salary and the percent of increase. So the amount of change equals what percent of original. We don't know the amount of change here, do we? That's what we're trying to find. His increase was 8%. And the original amount was $43,500. So we're finding the amount left out of percent. When I take 0.08 times 43,500, I get $3,480. That was the answer to the first question. That was the amount of increase. Then we want to know what his new salary was. Since this is an increase, we're going to be adding, aren't we? We'll take his 43,500 and we'll add 3,480. So his new salary will be $46,980. So there's our two answers to our questions. The last problem down at the bottom of this page, I'm going to save that for another video that's coming up. So there is some percent of increase and decrease and some applied problems.